Polynomial regression. Polynomial regression is an extension of linear regression that models the relationship between the input features and the target variable as an nth degree polynomial. It can capture non-linear relationships in the data by adding polynomial terms to the features. Now let's go and implement this. Here's a line by line breakdown of the code for implementing polynomial regression in Python. I've created a file called as polynomialregression.py, and let's go over one line at a time. First, let's import the necessary libraries. We're going to import sklearn.linearModel import linear regression, which imports the linear regression class from scikit-learn, which we'll use to create a linear regression model for polynomial regression. This model will fit a line to the transformed polynomial features. Next, from sklearn preprocessing, import polynomial features. This imports the polynomial features class, which is used to generate polynomial features of a specified degree. This transformation allows a linear regression model to fit a non-linear relationship by adding polynomial terms. Next, from sklearn model selection, import train test split. This imports the train test split function to split the dataset into training and testing sets, enabling evaluation of the model's performance on unseen data. Next, from sklearn.metrics, import mean squared error. This imports the mean squared error function to evaluate the model by calculating the mean squared error or MSE between actual and predicted values. Lower MSE indicates better performance. Next, we will import numpy as np. This imports the numpy library for creating arrays and performing numerical operations in Python. Let's start with the sample data. In this particular example, I'm going to use experience versus salary. So for my experience, I'm going to say, depending on how many years of experience you have, 1, 2, 3, 4, 5. So this x defines the feature data x as a numpy array where each value represents the years of experience. The shape of x is 10, 1, meaning it has 10 examples with one feature each. Next, I have y equal to np array, and I have the salaries over here, which defines the target data of y as a numpy array where each value represents the corresponding salary. The relationship between experience and salary is nonlinear, making it suitable for polynomial regression. Let's split the data into training and testing sets. For that, I'm going to use the same train test split, which splits the data into training and testing sets. We get xtrain and ytrain used to train the model, and xtest and ytest used to test the model's performance. The test size is specified as 0.2, which means that 20% of the data will be used for testing, with the remaining 80% for training. A random state is set to 42, which sets a seed for reproducibility, ensuring the same split each time the code is run. Now let's go ahead and transform features into polynomial features. This can be done using first poly equal to polynomial features degree of 2. Now this initializes a polynomial feature object with degree 2. This means we'll transform the feature x into a second degree polynomial, adding squared terms to represent the nonlinear relationship. Next, I'm going to say xtrain poly equal to poly.fit transform xtrain, which transforms the xtrain data into a polynomial features. For degree 2, this transformation will add an additional column representing x square alongside the original feature, allowing a linear regression model to fit a quadratic curve. Next, I'll say xtest poly equal to poly.transform xtest. This transforms the xtest data into polynomial features using the same transformation. We only call transform, not fit transform, to ensure consistency with the training data transformation. Next, let's go ahead and initialize and train the model. To initialize the model, I will say model equal to linear regression. This initializes a linear regression model. This model will fit a linear relationship to polynomial transform data. Next, I am going to say fit x train poly y train. This trains the model on the polynomial transformed training data x train poly and target values y train. The model learns the relationship between the experience in polynomial form and salary, allowing it to capture non-linear patterns. Next, let's say make some predictions. I'm going to move this up so we can see clearly. Ypred equal to model.predict x test poly. This uses the trained model to make predictions on the test set x test poly. These predictions are based on the polynomial features of x test, allowing the model to output salary estimates based on years of experience. Next, let's do evaluate the model. So first, we'll do MSE, mean squared error, y test, y pred. This calculates the mean squared error between the actual values y test and the predicted values y pred. MSE provides a measure of the model's accuracy with lower values indicating a better fit. Next, let's print the mean squared error. This prints the calculated MSE to evaluate how well the model performs on the test data. And this prints the predicted salary values for each test sample, allowing us to compare them against the actual y-test values. Now, this code here demonstrates how to use a polynomial regression to fit a non-linear relationship between years of experience and salary. By transforming the features into polynomial terms, we allow a simple linear regression model to fit a curve to the data. So let's go ahead and run this example. I'm going to open terminal. Python polynomial regression.py, and it will give me the mean squared error and the predicted values for the salaries right here. So I hope you were able to follow along in implementing polynomial regression. And if you have any questions or comments, let me know in the comments and I'll get back to you.